Vertical motion, two masses 2 kg and 0.5 kg are tied to the ends of a light string over a smooth pulley fixed at the edge of a table. The largest mass is resting on the smooth horizontal table and the smaller mass hanging vertically. Find the tension in the string. First, let's make a figure based on this. Let it be the table. The large mass rests on the table. Let it be the large mass. And the smaller mass hanging vertically. By means of a pulley. Let this be the pulley. Larger mass 2 kg. Let it be M1. Smaller mass 0.5 kg. Let it be M2. The tension of the string, that is T. Now let's see the forces acting on each mass. Let the acceleration of the system be A. The forces acting on the mass M1, tension force T is equal to M1 into A. And the force acting on M2 weight M2 acts downward, M2Z, tension acts upward, then forces acting on lighter mass is M2Z minus T is equal to M2A. Let's add these two expressions. We can get M2G is equal to A of M1 plus M2. Then substitute the values of M1 and M2 and Z to get acceleration. A, M2 0.5 into acceleration due to gravity is 9.8, approximately equal to 10. G is, let us take this as 10 meter per second square. 0.5 into G, 10 is equal to A of M1 is 2 plus M2 is 0.5. Then it is 5 is equal to A of 2.5. Then A is equal to 5 by 2.5. That is equal to 2. That is the acceleration of the whole system. A equal to 2 meter per second square. Now let's find the tension. Force T is equal, according to the equation 1, T equal to M1 into A. M1 is 2 into A is 2. Tension force is 4 Newton. On vertical motion, another model. Two masses 1 kg and 3 kg are connected by a massless string. The string passes over a frictionless pulley. Lighter mass is resting on the table. Calculate the force required this mass on the table. So let's make the figure first. Let it be the table. The lighter mass 1 kg resting on the table. And 3 kg suspended in air by means of a string passes through a pulley. Let this be the pulley. This is the given situation. This is of 1 kg of 3 kg. Let it be M1 and it is M2. The force required on the lighter mass to keep it at rest. Let T be the tension of the string. Simple, apply the forces acting on each body. Force acts on first body on M1 F. Tension acts in opposite direction, F minus T. To keep the body at rest, please note that the body is at rest, there is no acceleration. So, M1 into A, that is F minus T is equal to M1 into 0. It means F is equal to T. Now go to the forces acting on the body M2. Its weight acts downward, M2G. Force acting on M1. This is the direction of the force. Then this body also experiences a force upward. Then tension force dominates, T minus M2G, that is equal to M2 into A. T minus M2G, as the body is not in motion, then M2 into acceleration is 0, then T equal to M2 into G. Then substitute the values of M2 and G. That is equal to T equal to M2 is 3 kg into G is nearly equal to 10, T equal to 30 Newton. From first equation, F is equal to T is equal to 30 Newton force required on the body M1 to stop it to move. I mean to keep it at rest on the table. 3 blocks P, Q and R masses 1 kg, 2 kg, 3 kg respectively are suspended from a rigid support by the light inextinguishable strings as shown in figure. Find the tensions in the string supporting masses. So as shown in figure, so figure is given below. Let's make that figure. This is the rigid support. Three masses. One kg, 2 kg, 3 kg. One kg, 2 kg, and 3 kg. Tension, let here the tension force is T. This is T1 and it is T2. Its weight acts downward. That is m into z, 3 into z. One by one, let's go to each body on which the force is acting. Let's start with the 3 kg body. Weight acting downward, tension force acting upward. Then T2 equal to three Z. Equation 1. Then forces acting on first body, 2 kg body is T2 minus T1. That is equal to even this weight it acts downward. Two kg weight acts downward, then 2g also acting downward. That is equal to 0 as the bodies are not in motion. Then T2 plus 2g is equal to T1. Equation 2. Go to 1 kg body, weight acting downward, then forces on 1 kg body, T1 plus 1 into z minus T is equal to 0. Then it is T1 plus g is equal to T. That is equation 3. We got already T2 value. Now let's find T1 value from equation 2. T2 is 3z plus 2z, that is equal to T1. Then T1 equal to 5z. Now it's the turn of T. Go to third equation. T1 plus z equal to T. T1 is 5z. Then 5z plus z is equal to T. And T equal to 6 into z. We got all the tension forces. 1 T is 6z, T1 5z, T2 3z.